Now, one interesting thing that we can do in Objective-C is we can pass any message to any object. And we can really see this example with ID if we create a new object and we pass getArea to it, even though it doesn't inherit from square or circle. So one thing that we can do is we can actually pass this getArea message to any object. So we know we have the square comparer class, and this square comparer class does not have a getArea method. But we could create a square comparer and set this. So let's go ahead and try this real quick. We'll do object equals, and we'll do square comparer alloc init. Now this doesn't make much sense to do, but we're actually going to call getArea on it, and let's watch and see what happens here. So you can see we got an exception thrown at runtime. It actually compiled our code and it actually ran it, but the problem is unrecognized selector sent to instance. So square comparer doesn't actually have getArea. But because we defined our type as ID and we had set our ID type or our object to square comparer, the compiler had no way of knowing that getArea didn't exist on this object, which was set to square comparer, and so it called it anyway. Now what might surprise you further is that we can go ahead and we could put a getArea method on square comparer. So we can go ahead and implement this real quick. We'll do, and this doesn't make sense to do, but we're just going to look at this example to see how this polymorphism can apply. And we'll go ahead and do int getArea. And so we'll return 0 in this case. So now, if we run this, you actually get that area is 0 because it actually is called getArea. And the important thing to recognize here is that this square comparer has nothing to do with shape. It inherits from NSObject. But because Objective-C is dynamically typed, because ID can represent anything and you can pass a message to any object, you can actually use different classes that aren't even related in an inheritance hierarchy with the same pointer, the same object pointer. So the value of this really is in things like, let's say that you had some set of classes that weren't necessarily related to each other by inheritance, but they all had a print method, and you knew that they did. Well, you could use one variable, and you could loop through them. You could store them all in the same collection or same array, and you could loop through each one of them, and you could call the print method on them. So this is kind of a useful technique. It's definitely something that puzzles a lot of people that are not familiar with Objective-C. The basic idea here, though, is that you can use object. If you use ID here, it can represent anything and you can pass any message, and it doesn't have to be in the inheritance hierarchy. Now, just to show you real quick, if we change this back to shape, so I'm going to go ahead and try, we can assign a circle, but we're not going to be able to do this assignment here. You can see it's giving us a warning already, incompatible types, and then if we were to call shape getArea, and actually if we go ahead and try to call this, because this is just warning us that it's not the correct type and this is a dynamic language, it's actually going to let us do this. So I'm going to go ahead and run this, and you can see that it printed the area is 0. And so it's kind of strange here, but what's happened is we've assigned this shape pointer to some object that has no relation to a shape at all and called getArea on it. Not something that you want to do, but just an example to help you understand exactly how the dynamic aspect of Objective-C works with objects and messages.